Welcome, kiddos! Let's talk about single replacement reactions, and we are going to be featuring the activity series today.
Oh, sounds very interesting.
Get excited, everybody! All right, so let's talk about the activity series, and here is where you would find it. As soon as I get this up. Okay, this is the back of your periodic table.
Okay.
Very important that you guys know how to navigate your resources. So, on the back where your polyatomic ions are listed, if you look over on this side right here, that is your activity series that you will be using when we look at single replacement reactions.
Okay.
All right, so let's talk a little bit about what single replacement reactions are and how we identify whether they happen or not.
Okay. They should already know what single replacement reactions are.
Okay.
So we did a lab using a single replacement reaction.
Oh, we did do one. We actually did a single replacement reaction lab with this guy. We did aluminum plus copper 2 chloride yields aluminum chloride plus copper. And we can balance this reaction. Okay. So you guys did this reaction. You put some aluminum foil into a copper 2 chloride solution, mixed it up, and copper came out, right? Well, so why did this happen? Well, what happened was you actually got copper out of the solution.
As a precipitate.
As a precipitate.
It fell out of the solution.
Right, but why did that happen? So what we got to look at here is a couple of things. So we look at aluminum and copper, which are the two metals in this reaction. And in order to figure out if aluminum is going to replace copper with the chloride in the solution and the copper is going to come out, we'd have to look at the activity series, which is over here on the left. Now find aluminum and copper on the activity series.
Aluminum is right there.
Here.
Okay.
And copper is right here. Now if you notice, the higher you go up on the list, the more reactive or active these metals are. So aluminum, since it is higher than copper on the activity series, is going to
replace copper.
Replace copper.
Okay.
Because aluminum is much more attractive than copper.
I think the copper's prettier.
Whatever. Activity series doesn't lie. Anyways, so that's why this whole reaction happened, is because the aluminum was higher on the activity series than copper, kicked the copper out of the couple, and copper was left as the third wheel. Now, here's the thing. What if, let's write this reaction again. We have, and I'm not going to balance it this time, copper plus aluminum chloride. Is that going to yield copper 2 chloride and aluminum? Does the reaction happen that way?
No.
Why not?
Because the copper is less reactive than the aluminum, so the copper can't come back in and kick the aluminum off. Okay,
so that is why this reaction does not take place. So what if I wanted to get that, let's see, let's find something that does work. Let's say I wanted to get that aluminum out, but I can't use copper, right?
So according to the activity series, we'd have to use something that is higher up or more reactive than aluminum.
Okay. So what is more reactive than aluminum in this case?
Well, magnesium, sodium, calcium, barium, potassium, lithium.
What do you want to use?
Calcium.
Let's use calcium. So calcium is higher up on the list. So if we just added calcium to aluminum chloride, it would kick aluminum out. It would make calcium chloride.
Oh, and then we can make pickles.
Always about pickles. I don't understand this. Of course, this is unbalanced, but this would actually happen because calcium is higher on the activity series.
So we can get the aluminum back.
We can get the aluminum back. We just can't do it with copper. All
Very
right.
Cool.
Let's try one more real quick. Let me erase all this stuff. So let's pretend that, I don't know, we have magnesium chloride.
Okay.
I like those chlorides. I'm just going to leave a bunch of space. How do I get magnesium out of there? If magnesium is right here, what could I use to get magnesium out?
Well, you need something more reactive than magnesium.
Which would be?
Anything above it. Sodium, calcium, barium, potassium.
Don't say calcium again.
Let's do potassium.
Okay, potassium, great. If we use potassium, which
just
is...
use a banana.
You can't just use a bit... Never mind. All right. Potassium could kick out magnesium. Therefore, it would make potassium chloride. And I know it's just KCl because of oxidation numbers. and that's what would be left over. This is unbalanced, of course.
And then an important point is magnesium would be a precipitate, so it would actually
yes.
fall out of the solution. So whichever one is kicked out is a precipitate.
Precipitate. Precipitated. Yeah, great. Okay, so let's talk about one more thing, and that is the activity series of halogens. Now, the halogens, remember, are group 17 right here, and how do we know which one of these is more reactive? Well, the actual trend is going up.
Okay, so fluorine would be more reactive than chlorine.
Yes, and it's just actually all nice and ready for us here. So fluorine is the most reactive. It would replace chlorine, bromine, iodine, and those types of things. Let me show you an actual reaction where that takes place. So let's say we have, I don't know, fluorine gas, which is F2. Because it's diatomic. Added to something like, again, let's keep that magnesium chloride in there. Okay, that would make what? Well, magnesium would still stay in there because fluorine cannot replace magnesium.
Okay.
Fluorine's a nonmetal, it has to replace another nonmetal.
Okay.
So fluorine would replace the chlorine right here because it is more reactive. So we would get magnesium fluoride plus chlorine gas, which would be Cl2 because it's diatomic also. All right. So that's pretty much the activity series for halogens and for metals.
Sounds good.